You know what really grinds my gears is when they change opening day for trout season to yesterday, the 7th, but didn't let anybody know until the 7th. That means when I went out at the end of school yesterday, all the fish had been taken. It was very sour, or salty, or whatever term you guys use today to describe bitterness, hatred of those who took more than the allotted 5 fish. But still ended up doing well. But let's get started. We're going to start with chapter 8. You guys can get these notes, print them out if you can, or take notes on note paper. They're under chapter 8 on Schoology. I'll post the answer key when I complete it, but you know, husky packet, so it might take me a little longer to get that answer key up. So you guys are really going to have to follow along until that happens. So let's get going here. Chapter 8 is all about solving quadratic equations. Now, if you were to ask me at the beginning of the year, what is Algebra 2? Okay, I would say the main difference between algebra and Algebra 2 is algebra is all about linear equations, like y equals mx plus b, solving systems, okay, you have inequalities. Basically, everything you deal with has an exponent of 1. It's linear, all right, it has a degree of 1. You get into a little bit of factoring at the end, but Algebra 2 really picks up with quadratics. And notice Algebra 1, degree 1. Algebra 2, we're going to be talking about things that are degree 2. So really, to me, Chapter 8 is crucial in Algebra 2 and really understanding further mathematics. So, oh, that's some good water. Without further ado, Chapter 8, okay, and it's quadratics. All right, so the objective is to solve a quadratic equation. There are many different ways to do it. I probably know of like 4, maybe 5. I don't even know how many ways I know to solve it. But each, I guess, equation has a way that can be solved the best. Okay, what do I mean by that? Well, this is one equation. Okay, this is A under concept opener. And if you look at B, you can see that these two equations are very different, okay? Let me try to block out that sun. There we go. So they are very different, okay? This is y equals 2x squared plus 3x minus 5, and this is y equals x squared plus 4. I would solve these in 2 very different ways. First one. Okay, let me get rid of B. What do I do? Where do I go? Basically, with this, you're going to have to kind of, I would start with either using your calculator to graph it, okay, or I would try to factor. Now, if you're going to graph it, okay, you're going to go to y equals, okay, on your calculator. So I'll try to write these down for you. Okay, so you're going to hit y equals. This is in the upper left-hand corner of your calculator. Then you're going to type in 2x squared plus 3x minus 5. All right, so you're going to type that in, and then you're going to go to graph, okay? And since I can't display this on the screen for you guys to see, and there's really no way for me to do it on the calculator, yes, I have it, but you guys know I don't like to use it. When you graph it, you're going to get a parabola. All right, it's going to be in a U. And it's, for this one, going to open up. And what you're going to do is you are looking for where your graph crosses the x-axis, okay? And this is crucial. To solve means to find the x-intercepts, all right? Or it means to find the zeros or roots, okay? Basically, in all of these, it's when y is 0. That's what I'm looking for, is what value of x makes y 0. So I'm looking for the intercepts. So you guys can go through and you can approximate them. I'm going to see if I can do it through factoring. All right, but these are your steps that you can use to kind of lead you into graphing on your calculator. And I'll go over more of that later on. So here, what do I do? All right, so I'm going to try and do the British method. That means 2 times negative 5, that's negative 10x. I'm looking for the factors of negative 10x that add up to 3. All right, so I'm going to do 2x squared plus 5x. Then I'm going to do minus 2x minus 5. Okay, so I have that. Those are my two factors that multiply to give me negative 10 and add up to give me that. So here, what do they have in common? That's an x, so I'm going to pull an x out. And that leaves me with 2x plus 5. What does this have in common? Well, that's just going to be a negative sign. So I'm going to pull out a negative 1, and that leaves me with 2x plus 5. Notice here, this and this are the same. So that means this can be factored to y equals, okay, 2x plus 5 times, okay, and I'm going to try and squeeze this in here, x minus 1. Hopefully you can read that. It says x minus 1. Now, why did I do all of that? Well, let me get rid of this. All right, so that was all my work. Okay, let me rewrite this here. All right, now, how do I solve this? Well, basically, I'm going to take 0, plug it in there. And then what I'm going to do is I'm going to solve each of these. I'm going to solve 0 equals 2x plus 5. I'm going to solve 0 equals x minus 1. So when I do that, let's start over here. And I don't really need the parentheses. I'm just going to add 1 to both sides, and I get x equals 1. Okay. So if you did it on your graph, all right, using your calculator, you're going to get a point on your graph where your x-axis and your graph cross, and that point is 1. So the point would be 1, 0. That should be on your table. It should be a point where your x-axis and your graph cross. And over here, okay, if I solve this, I have negative 5 equals 2x. I got that by subtracting 5 from both sides. Then I divide by 2, and I get x equals negative 5 halves. So the other point I have is negative 5 halves 0. Now what is this? Well, over here, okay, I had that point. That was where my graph crossed my x-axis. And over here, that is another point where my graph crosses my x-axis. So I have two answers. Notice I have 2 up here. That's why I have 2 answers. Okay? So when your degree is 2, you have 2 answers. So I solved that by factoring through the British method. Okay? Now, there was no way for me to do this problem other than graphing or that. as of now. There is a third way I could have done this, but that's for a later date or time. So I'm trying to use things I've already learned so that I can kind of expand later on and kind of fill you in. So right now I'm only using things that I've learned to date. All right, and we learned about the British method and we learned about graphing. All right, so B. Well, why is B so different? Okay, well, B is very different because, to be honest with you, there's less going on. All right? In the last one, I couldn't just solve by bullying my way through it. What do I mean by that? Well, I couldn't just set it equal to 0 and kind of like get all my x's to one side, but here I can. So what I want to do here is, remember, it's when y is 0 is solving a quadratic. So if I set y equal to 0, I have this. What I can do is I can subtract 4 and get this. Now, how would I solve? Well, I would subtract, or not subtract, I would take the square root of both sides, and I get x equals plus or minus 2i. So I would have this. That's one intercept, 2i comma 0, and the other intercept is negative 2i comma 0. Oh, this is strange and weird because I is not on my calculator. Well, this means that, all right, I stands for imaginary in my mind. So this means I have two imaginary intercepts, meaning this graph never crosses my x-intercept. The last one I had two real answers, okay, and that's where my graph crossed the x-axis. It crossed in two places. You could check that on the graph, but here if you were to graph it using the same process, well, it wouldn't. It would be slightly above. All right. Now, how would I go about solving C? All right, well, with C, okay, with C, well, again, I don't know how to explain it. It's just kind of years of doing it, but I'll do my best for you, okay? So in A, I tried to solve that by factoring, all right? And then B, I kind of pulled my way through and was able to solve for 0. So I'm going to try to do this in a combination of both those methods, okay? So what I'm going to do is I'm going to set this equal to 0, all right? And then from here, what I'm going to do is I notice they all have a 2 in common. So I'm going to pull that 2 out. So I factored this out. Now I look at this and I say, can I factor that? Now again, you could be typing this into your graphing calculator and seeing if there are intercepts, okay? The reason why I don't always do it that way is sometimes you might get like a decimal that you don't recognize. And this way, if you can factor it, you're going to be able to figure out exactly what it is. So here, all right, I notice that I can factor that. All right, the factors of 1 that add up to 2 are 1 and 1. So I'm going to factor this to x plus 1 times x plus 1. All right, so in this one, okay, I can divide everything by 2. Okay, so I have 0 equals x plus 1 times x plus 1. All right, and now if I were to solve each of those, I would get x equals negative 1 and x equals negative 1. Well, how did I get that? Well, I have 0 equals x plus 1 and 0 equals x plus 1. I subtract 1 from both sides. But notice, these are the same. So this is something we call a double root. Well, what does this look like? So the first one looked like a U that came down and went through my x-axis and crossed it 2 places. B never crossed my x-axis, so I was just a U that was above, my x-axis. And C, what does this look like? Well, this looks like a U that comes down and just kisses the x-axis at -1 and goes back up. So it just comes down and touches and goes back up. It doesn't cross it, it touches. So this is a double root. All right, so that's how I would go about C. And D, even though it looks scarier, well, guess what? It's not. Okay? So D, I'm going to go ahead and I'm going to solve this just like I have been. All right, again, you could type this in your calculator. All right, and you could graph it. Okay, but here we go. I'm going to set it equal to 0. I'm just going to try and bull my way through this problem. So I'm going to subtract 2. Those cancel. I have -2 equals x plus 7 squared. Now I'm going to take the square root. Okay? So notice I'm going to be getting some imaginary answers. How do I know that? Well, because there's a -2 inside that square root. So now I'm going to have plus or minus I root 2. Okay, now why did I pull out the I? Well, the square root of -1 here, okay? The square root of any negative number is going to have an I component, so I'm going to have plus or minus I root 2, okay, equals x plus 7. All right? Now, real quick, I'm just going to take over here before I erase my work. I'm going to go over here, and I'm just going to write this up. Okay, so how do I go from here to here? Well, I'm viewing the square root of -2 as -1 times root 2. The square root of -1, well, that's your I by definition. We learned about that last chapter. So that's where that comes from. And all square roots have 2 answers. So that's why it's a plus or minus. And I like writing it as plus or minus. Okay, instead of wasting ink and writing it twice, I write my answers with plus and minus. So now I'm going to erase this work, okay? Because I'm running out of room here. Okay, and I'm just going to move that up to the top so you guys can follow along. Okay, and now I'm going to go ahead and solve that. So how do I get rid of plus 7? Well, I subtract it. So my answer is x equals -7 plus or minus I root 2. And I like this. This looks real clean to me. Okay, my 2 answers are -7 plus I root 2 equals x. And I have -7 minus I root 2. So there's my 2 answers. Any questions? I know there's a lot of questions. I get it. You're struggling on it. It's new. But the thing is if you have any questions, reach out to me. I'm more than happy to work, sit down with you through a Google Hangout now. Okay? So just let me know, and I'm more than happy to work out with you and go through all these things. All right, so step 2 says, use a graphing calculator to check your solutions. Well, what do we mean by that? Well, it means take those answers we got and plug them in, okay? Now, I haven't shown you how to do the complex stuff in your calculator. That's going to be real difficult. I'm going to have to figure out a way to do that. Not quite sure how that's going to work, but you know, I think the best way for that is probably, you know, one day I'm just going to do a Google Hangout, and I'm going to ask you to bring your calculator. I'm going to talk to you about how to plug these things in. So I'm probably going to set that up. All right. Now, which graphs have x-intercepts and which ones have none? Well, if we're looking back at our answers, okay, our answers that have real numbers, meaning A and C, have x-intercepts. All right, those two, if you graphed it, cross my x-axis. All right, and if you're following along, we're at step 2B, okay, and Which ones don't? Well, the ones that don't are B and D. Now, why do they not have it? Well, they don't have it because they have an I in it, just like this. See the I? That means it's going to be imaginary. Okay? Yeah, I know that number is real, but that number is not, so therefore the whole number is not real. Now it says, compare the x-intercepts of a quadratic equation and the types of solutions. Okay, make a statement about their relationship. Okay, so if there are x-intercepts, okay, then I have two real answers or real solutions. If I don't have any x-intercepts, if I'm looking at the graph, if it doesn't cross, well, then I have no real solutions. Okay? The cool part about these are imaginary numbers come in pairs. I can't have one imaginary number. There's always two. Okay? So I can have 0, 2, 4, 6, 8. It's always in a pair. Okay? Now, real numbers, well, I could have one answer like we had in C. Okay? It was just x equals, I believe the answer was -1. All right, so I could have one answer, or I could have two answers, so those can come in different numbers. But imaginary numbers always come in pairs. So since we're dealing with a quadratic, either you have 0 or you have 2. You'll never have 1. All right? So right there, okay, that was the introduction, okay, to this stuff. What I'm going to do is I'm going to put up another video of me working through the examples, okay? And that's on the next page. So look forward to hanging out with you guys for that. All right.